Hello guys, welcome to Backbench Studies channel. I am Umesh Kumar and we are learning from past 6 lectures the steady state response of second order system and time domain specifications of this second order system. In the last class, we discussed how we can derive the peak time of this second order system, and we are left with this equation of peak time over here, which is T peak is equal to pi by omega d, where omega d is the frequency which is damping. So omega d is equal to omega n into square root of 1 minus delta square, where delta is the damping constant. So in this lecture we are going to learn about the maximum peak overshoot. So let us start. What is maximum peak overshoot? So peak overshoot is the value beyond the steady state value. So maximum value, it can reach the beyond this steady state value that we can depict from this definition over here. So let us see. So this is the time axis and this is the amplitude axis. So here we have time over here and here we have c of t amplitude over here. So the input which is given to this second order system is depicted over here, which is the unit step input. This value is equal to 1. So it should reach this value. Uh, Ideally, it should be like this, but it is not reaching like that. It is going to some higher value and coming back to this lower values, and it is kind of oscillating about this steady state value and reaching this steady state value at infinite amount of time. But we don't require that. We don't require much higher values than the steady state value. This will lead to instability of the system. So the maximum, the more the peak overshoot is, the more unstable the system is. So this is how the system behaves. So this time we already derived that this is the peak time, the time required for the first time to reach its maximum value. And these maximum values are exponentially decaying. We already saw that. So this value from the bottom, this amplitude is what we have minus this steady state value is called as the peak overshoot. So this is the peak time. So we have the steady state value, which is when we place t equal to infinite in this equation, we are left with this 1. So the steady state value is equal to 1. So if we subtract this steady state value c infinite from this peak value c of tp, then we are left with this peak overshoot. So let us start. So this value which is depicted in the arrow minus the steady state value, this one, this value is called as peak overshoot. So let us derive. So we can write it as peak overshoot as mp is equal to c of tp minus c of infinity. So this value, this amplitude at peak time is equal to c of tp minus this steady state value c of infinity. So let us find out the c of tp. So this is the expression for the output we have derived. So if we substitute t equal to tp in this expression, we have this expression over here. So substituting tp is equal to pi by omega d, which we have derived in the last class, which is the time, peak time. So if we substitute pi by omega d in this expression, then we can have this kind of expression over here, because omega d and omega n are related. So omega d is equal to omega n into square root of 1 minus delta square. So this omega n will get cancels out, thereby resulting into del into pi by root of 1 minus delta square over here. And this in this exponential, and this one over here is same. And if we substitute this value, this omega d will get cancels out, and sine of pi plus theta will become minus sine theta, like this. So if we substitute sine theta is equal to root of 1 minus delta square, then we can get c of tp as 1 plus e exponential of minus del pi by root of 1 minus delta square, because this sine theta over here and this 1 minus del root of 1 minus delta square will get cancels, and this minus over here will get multiplied to make this as plus. So this is how, so this is the value of C of TP. So if we subtract this with the steady state value, which is equal to 1 from this expression C of TP, then we have the maximum peak overshoot. So MP is equal to exponential of minus del pi by root of 1 minus delta square. If we observe that this MP over here is is dependent on exponentially with respect to this damping factor over here. So that's all for today, guys. Thank you for this amazing session.